In this slide, we're going to cover the question of how do we plot a quadratic function, a parabola, by hand, roughly. Here we're assuming that we don't have a graphic device. When that would happen, usually when we are faced with a problem that asks us to produce a graphic function by hand, or if we are in an exam where we do not have a graphing device on us, if the exam is no calculators. Okay, so let's see how that is done. When we plot a parabola, the first thing we do when we plot a quadratic function or a parabola, the first thing we do is we find the vertex, the tip of the parabola. The next thing we do is we find the y-intercept of the parabola. The y-intercept is simply its x-coordinate is always 0 and its y-coordinate is the value of the function at 0. Next we find the x-intercepts, if any. Next, we adjust the size of the axis to fit the whole picture. And finally, we plot the parabola freehand by simply connecting the dots. Now, if the parabola has no x-intercepts, we can only use the y-intercept and the vertex, and then we can just freehand our parabola. If a is greater than 0, the parabola should open upwards, and if a is less than 0, that's the leading coefficient, the parabola should open downwards. If the absolute value of a is greater than 1, we should aim to draw the graph steeper, and if the absolute value of the leading coefficient a is less than 1, we should aim to draw the graph flatter. So let's do an example. Let's plot roughly by hand the graph of negative 2/3 x squared plus 7x plus 3. Now, in the end of this slide, I'll be showing you how to do that. I'll be showing you the actual plot, and that will be plotted by a computer. But hopefully, following the instructions in this slide, you'll be able to reproduce a somewhat accurate version of this plot by hand. And the version should be accurate enough so that you can get a ballpark estimates of where the graph of the function lies. All right, so let's do that. As said, our first task when plotting a quadratic function by hand is to find out where is the vertex. So, what is the x-coordinate of the vertex of the parabola given? I'm sure you guessed it correctly. The x-coordinate of the vertex of a parabola, as studied, is given by negative b over 2a. Here b equals 7, so b is 7, that is 7. And a is negative 2/3. A is negative 2/3. Now we can simplify a little bit. The 2 minuses become a plus, and the 7, the 2 times 2 is 4, and the 3, when it's transferred upstairs, it becomes 7 times 3, and 7 times 3 is 21. Okay, so the x-coordinate of the vertex of the parabola is 21/4. Now, the y-coordinate of our parabola. If you remember, we studied a ready-made formula for the y-coordinate of the vertex of a parabola. But that formula is a bit tricky to memorize. It's relatively long, so rather than memorizing it, all we need to do is remember that to get the y-coordinate of the vertex of the parabola, all we need to do is take the x-coordinate of the vertex of the parabola, which is negative b over 2a, and put that inside of the formula for f. Now, we're guaranteed, when we do that, to get minus the discriminant over 4a, which is the same as negative b squared minus 4ac over 4a. So we're guaranteed to get that, If you remember, we studied that that is the y-coordinate of the vertex of the parabola. If you remember, that was actually the constant term that is obtained when we complete the square. So we know that we have a ready-made formula, but please don't memorize this. So don't memorize that. That's too much to memorize. Just memorize that we are plugging minus b over 2a in place of x. So we're replacing minus b over 2a for x, and we just uncover all the parentheses. Okay, so let's do that. So what we're going to get is, okay, in this slide, let's use the shortcut formula. We know that we're getting minus b squared minus 4ac over 4a, and here b is 7. Okay. A is negative 2/3. And C is 3. C is 3. So that's what we get. Now 3 and 3 cancels. Minus times minus becomes a plus. 4 times 2 is 8. And 7 squared is 49. Those two minuses here become pluses. Those two minuses become pluses. And 4 times 2 is 8. Now 49 plus 8 is 57, and the 3 in the numerator jumps upstairs, so that becomes 3 times 57 divided by 8. Or altogether we're getting, well, 3 times 57 is equal to 3 times 50 plus 3 times 7. Which is equal to 150 plus 21, which is equal to 171. Okay, so we get 171 eighths. So that is our y-coordinate. So what happens if for some reason you cannot remember this formula? So you cannot remember that the y-coordinate of the vertex of the parabola is minus the discriminant over 4a. Well, you don't need to actually memorize that formula. All you need to do is compute f of the x-coordinate of the vertex of the parabola. So all you need to do is compute f of 21/4, right? When x is equal to 21/4, we're at the vertex of the parabola. So all you need to do is take f of 21/4 and compute that. Now I'm going to need a little bit of space in order to compute that number, so I'm going to leave a little bit of space here. So let's do it. F of 21/4 is negative 2/3 times 21/4 squared, right? So here is my negative 2/3, and x squared, that's 21/4 squared, plus 7 times 21/4 plus 3. So that gives me, let's see, negative 2 times 21 squared. I happen to have memorized that that's 441. Of course, you can compute it on the side. Divided by 3 times 4 squared. Plus 7 times 21. Now 7 times 21 equals 140 plus 7. Right, because that's 7 times 20 plus 7 times 1. Which is 140 plus 7, which is 147. So that's 147 divided by 4 plus 3. So that gives me minus 882 divided by 4 squared is 16, and 3 times 16 is 48. You know what? It may be a better idea here to cancel 2 and be left here with 8. So rather than using 48, I can use 24 here, and here I could use 441. Plus 147 divided by 4 plus 3. Okay, so now I have to put this in the common denominator. So in order to put this in the common denominator, I'm going to multiply by 6 here and multiply by 6 there. In this way, this becomes equal to 24, so I can put these two together in the common denominator. So minus 441 plus 6 times 147 divided by 24. And I also have to put 3 in the common denominator there, so 3 times 24 divided by 24. Okay, so let's proceed. Minus 441, 6 times 147, what's that equal to? Well, 6 times 100 is 600, 6 times 40 is 240, and 6 times 7 is 42. So I get 882. So plus 882, the whole thing divided by 24, and 3 times 24. So I can put things in the common denominator. 3 times 24, of course, this is 7. So the number of hours in 3 days is 72. So that's an easy one. 72 there. So we get 882 minus 441, that's 441 plus 72 divided by 24, which equals, that equals 513 divided by 24. Let's check this fraction. The top appears to be divisible by 3, so I can cancel out a factor of 3. 513 divided by 3 equals 513 divided by 3 equals, I guess 1, then you put 1 times 3, so 1 here, so 1 times 3 is 3, you subtract the 2, you get 2, then 21 divided by 3 is 17, and then 3 divided by 3 is 1, so 171. Okay, so alternatively, you know that 3 times 170 is 510, and 3 times 1 is 3, so when you add the 2, you get that 3 times 171 is equal to 513. So we get 171 over 8, which is exactly the same number that we see here. Now you can see that these computations can be rather laborious. So of course, for the practical purpose of doing this on an exam, you want to use a calculator if you have one available. So you'll be doing these computations when you do not have a calculator on you and you're being asked to plot that function, or you need to plot that function. Okay, so we saw that if the x coordinate of the vertex is that since the x coordinate of the vertex is 21/4, then the y coordinate is 171/8. Okay, so that means that my vertex, this is its x coordinates and this is its y coordinate. Okay, so now let's compute the y-intercept. The y-intercept of a quadratic function, that's simply the value of the function at 0, right? That's where the function intersects the y-axis. So what's f of 0 equal to? I'm sure you guessed it correctly, 3, right? Because I'm replacing x with 0 here and here, and so you can see that f of 0 must be equal to -2/3 times 0 squared plus 7 times 0 plus 3. Well, all that remains, of course, is 3. So f of 0 is 3. Okay. So my y-intercept is at y equal to 3. Now let's find the x-intercepts. So to find the x-intercepts of our parabola, we need to solve the equation negative 2/3 of x squared plus 7x plus 3 equal to 0. Let's do that. First, when we solve a quadratic equation, we can clear the denominators on both sides. So we can multiply both sides of this quadratic equation by 3. Now, when you multiply 0 by 3, you still get 0. When you multiply 3 by 3, you get 9. And when you multiply 7 by 3, you get 21. And when you multiply 2/3 by 3, you get 2. So that's what we get there. Okay, so what's x equal to? So how do I solve that quadratic equation? Minus 2x squared plus 21x plus 9 equal to 0. I'm waiting for your answer. The solution for x is, I'm sure you guessed it correctly, the formula. I wasn't actually asking you to simplify the whole answer. That would be too much to do so fast. But we remember that the formula for solving a quadratic equation is minus b plus or minus radical of b squared minus 4ac over 2a. Once again, I want you to memorize that formula by heart. Okay. So here b is 21. B is 21. A is negative 2. And C is 9. Now it's quite a bit of expression to simplify, but let's not be shy from computations. Let's simplify. 21 squared. That's 441. I personally have the squares of the first 30 numbers or so memorized for the practical purpose of solving exam problems. But if you don't, you can just derive it on the side. So 21 times 21, that's 1 times 21, and then 2 times 21, which is 2, and then 4. And then you add the two things together and you get 441. So 21 squared is 441. And minus with minus gives you a plus. And 4 times 2 times 9, well, 4 times 2 times 9, that's 8 times 9, which is of 72. So we get our 72 there. Okay, now this minus, the minus that's in the denominator, it can jump upstairs. So that makes this minus become a plus. And this plus minus, it becomes minus plus. That's just a minor detail. Okay. Now 441 plus 72, that's of course 513. And let's see, can we simplify that a little bit? Yes. 513 happens to be 9 times 57. Let's check that quickly. 9 times 57, that's 450 plus 63, which is 513. Now, how can you factor the expression 513 as 9 times 57? Well, we already saw in our previous computations that 513 was divisible by 3, and then you can continue to factor out. If you remember, 513 was 171 times 3, and you can additionally factor 171 as 57 times 3. So we can do that. Now we can. Why should we do such a factorization to begin with? Well, because we can split radical of 9 times 57 as radical of 9 times radical of 57. And now we can simplify radical of 9 to 3. So we get 21 minus plus 3 times radical of 57 divided by 4. And that's as simple as we can get. So, so we have our x-intercepts. So I have copied my x-intercepts here. Here are my x-intercepts. Here's x1 and here's x2. All right. So now, by the way, I want to stress the fact that one of the reasons that I'm doing all computations by hand here, rather than with a calculator is that I'm assuming that I do not have access to a calculator, right? Because if I did have access to a calculator, I would just, of course it would be a scientific calculator, so I would just plot my function. So it is assumed that I do not have access to a calculator. So it is important to carry out all computations by hand. All right, so now, so let's select our scale so that we can fit the picture, right? So I actually now have to go ahead and plot all of these points on my coordinate axis. But where do I plot them? How large are these points? Well, the first thing is I need to figure out the x-coordinate of the tip of the parabola. Now, 21/4, that's approximately equal to 20/4, which is 5. So, so that means that I'm going to need 5 ticks. I'm going to need approximately 5 ticks. 1, 2, 3, 4. So 5 ticks for the tip of my parabola. Okay. Now 171 over 8. I need to estimate how large is that number without the use of a calculator. Well, let's see. 8 times 20, that's 160. 8 times 21, that's 160 and another 8. And 8 times 22 is 168 plus another 8, so that's 176. So that means that 171 times 8, so that means that 8 times 21, which is 168, that's less than 171, which is less than 8 times 22, which means that 171 divided by 8 must be between 21 and 22. So it's somewhere between 22 and 21. So 171/8 is between 21 and 22. Once again, I'm not using a calculator. I'm doing these computations by hand. So for the vertex of my parabola, I need to, its x-coordinates is 1, 2, 3, 4, 5 ticks away from the origin, approximately 5 units, and its y-coordinate is approximately 20 units. So it's approximately 20 units. Now 20 is about 4 times 5, so I'm going to have approximately the distance that you see here. I'm going to have to mark it 5 times. Whoops, I'm going to run out of space here. So you see that I have to be careful when I select my scale. So if I want to make a good accurate drawing of my quadratic, I need to make sure that the x-coordinate of the vertex of my parabola is about 1/4 of the y-coordinate of the vertex of my parabola. So this should be taken into consideration when you try to plot a parabola by hand. Okay, so now let's see. There are more things we need to fit in our picture. So before we actually fix the scale of our picture, let's try to estimate this number and that number by hand. Now, 21 plus 3 times radical of 57 over 4. Well, radical of 57, that's a nasty quantity. It's difficult to estimate without a calculator. But we remember that 57, that's not a perfect square, but it happens to lie between 8 squared and 7 squared, right? That's 64, and that is 49. So that means that radical of 57 must be somewhere between 7 and 8. Which means that I can approximate radical of 57, I can approximate it with radical of 64. Why do I choose radical of 64 and not radical of 60 or something else? Well, because radical of 64 is very easy to compute. So I can estimate radical of 57 with it's approximately equal to radical of 64, radical of 64 of course is 8. So 3 times radical of 64 is 8 times 3, which is 24. So that's what I get. So I'm getting altogether 45/4. So this number here is approximately equal to 45/4, which is approximately equal to 44/4, which is approximately equal to 11. So about 11 units for this guy. Similarly, this this quantity here, is close to 21 minus 3 times radical of 64 over 4. So that's 21 minus 24 over 4, which is negative 3/4. So, so this quantity here is about negative 3/4, right? Which of course we can approximate it as that should be approximately -1, right? Because our scale will have to fit quantities as large as 20 units, and when you have when you have to plot such a large quantity, it will be difficult to be very precise about small quantities such as -3/4. Okay. So now, so the parabola, the vertex of the parabola is less than 22 units high, and the parabola opens downwards. So what we can do is we can apply a scale. So this distance here is going to be about 22 units. 22 units. Now I've actually used the computer. This is a computer-generated plot, so this is exactly 22 units in the measurement unit of this picture. But when you plot that by hand, you're going to say, well, this distance about 22 units, that's the y coordinate of my vertex, and this distance here is about 5 units. So this distance here has got to be about 1/4 of that distance. So when you actually plot that by hand, you're going to mark this distance here first, and then you're going to mark the same distance, four times upstairs, about four times that distance upstairs. As you can see, it doesn't quite match. When I tried to mark this distance 4 times on the y-axis, I got a bit higher than this point. Well, that happens. Okay. So now it is time for me to enlarge the axis of my picture, right? So if you notice in the beginning, I had selected a smaller axis. By the way, this very much happens when you do when you plot things by hand, right? So when you plot things by hand, you usually select a random scale on your axis. You may even mark it. You say this is 1 unit or something of the sort, and then later on you change your mind and you rescale your picture. So in this case, I'm going to rescale the axis. I'm going to elongate them so that the highest point on my axis is 22 units. That's reasonable because that's the highest. The highest point I'm going to have to draw is about 21 units, between 21 and 22 units. A grid of width 3 units appears reasonable. Now, for this grid here, you may actually have grid paper provided to you when you're on an exam. So that may be very easy to achieve, to have a grid paper. And you can select the unit of the grid paper to be 3. Alternatively, you can approximately plot that by hand with dotted lines, and if you spend enough time, you'll be able to get a reasonably good grid. Okay, so let's plot all the relevant points. The y-intercept was at y equal to 3, so that's going to be exactly 1 unit on the grid. And now the x-coordinate, so this was one of the x-intercepts. So the x-coordinate of one of the intercepts was -3/4, which we said was about -1 unit. So if this here is 3 units, if this distance here is 3 units, then you have to go approximately 1/3 of that distance and a little bit to the right. So somewhere there, where marked. And then we have to also plot this quantity here. We saw that this quantity was approximately equal to 11. So it's going to be 3 units here, 6 units there, 9 units there. It's going to be 12 units. So it's going to be somewhere here. So this point is going to be somewhere there. Let's see the computer-generated plot. Oh, I was pretty close. As you can see, I would have done actually a good job by hand. And finally, we have the vertex of our parabola. We have the intercepts. It's time to connect the dots. So let me connect the dots right now. Now, I'm going to show you the computer-generated plot, but before revealing it, I'm going to try to freehand this plot, to freehand this, as I would do on an exam. So I'm going to use these points and try to plot everything myself. Now, I'm not using a real pen, I'm using an electronic pen with a tablet, so it is a little bit less accurate than an actual pen, but I'm going to try to do my best. So let's see how I do. I'm going to have a parabola. The tip of my parabola is going to be here, so this is going to be the tip. My parabola is going to open downwards, and it's going to be something like this. And here it's going to be something like that. You can see I did not do a fantastic job. Let me try to fix it a little bit. So plotting by hand is more challenging than by computer, and certainly plotting with a stylus is even more challenging. Let's see, now that's slightly better. And then again here I'm less than perfect, but I'm sure you can do a better job with an actual physical pen or pencil. Well, this is not perfect. This would if I were grading such a plot, I would not be taking off points. I see that it's not perfect, but you know, maybe your hand is not that steady, maybe you're not as very artistic, maybe you're like me, yeah, so I did not do a very good job. Let's see the computer generated plot. Here it is. Well, okay, I'm sure you do a better job than me, but if I were grading my own work, I would give myself, you know, I wouldn't take off credit. I would give myself an A minus, or okay. This is an okay job. Okay, so we consider this problem solved. Just I want to recap for you the rules for plotting a parabola by hand, just to remind you of all the rules. Find the vertex of the parabola. So find the x, so x coordinate is negative b over 2a, and then f of negative b over 2a gives you the y coordinate. Find the y-intercepts, that's just f of 0. Find the x-intercepts by solving the quadratic. Then you get your points, and then actually getting those points on the grid was a big effort. If you remember, we had to do a lot of by hand computations to get ballpark estimates as to where these points are located, right? Because we had to do all of that without a calculator. And once we have all the points on the grid, we just try to freehand them. We try to connect them freehand with our pen, making a parabola-like shape, a cup-like shape, and if we're lucky and we have artistic ability, we're gonna get a good final